come and get it.
Jeremy Ellis here, maker of rocksetta.com, Twitter @rocksetta. This video is about Particle.io's Photon used in the classroom. Part of a robotics electronics course, this video is only dealing with the Photon part of it. You'd still got safety and resistors, diodes, transistors, capacitors, electrical circuits. You've got a bunch of physics you can cover, but this is the Photon side. 54, I've taught coding for about 30 years. I've got a chemistry degree, an education degree, a diploma in counseling, and this course is really exciting. I've only been doing robotics and electronics for about 3 years, still making lots of mistakes. That's part of the reason why I stay to under 12 volts and under, and 2 amps for most of the projects for the students. In fact, I prefer 6 volts and only about 1 amp. Lots of problem solving. I get the students to do 3 final projects. I'm really happy if they complete one of them. And basically everything's out of Particle. Here, check this set. There's community, great for help. There's the console, I'll flip to that. I do use the snap circuits. Here are the snap circuits. The first layer, I got the Photon there, and a bag of snap to pins. And there's the main tray with this removable piece. Really useful, really easy. Lots more experiments than you can handle in a semester. Just a really good system. Really handy. They last a long time. I also use the Pololu site. And let's go through some of the particle stuff. There's the Photon. That's the kit I have. Here's the events page. Here's the IDE. All these things are important. This to flash the code, this to verify your code. I think these are 2 here. Let me see if I can see. That to save your code. This to look at the code. Here's the code page. You always have setup and loop to start with. And there to the libraries. They're really helpful. Help, documents, devices. That gives you information about your device. Console, that's the page we already looked at. And settings, that also gives you information. It's got the access ID. Your device, you can find your ID. This one has your access token. So there's the docs page. You search on the Photon. This is the community page. Here's my GitHub page. All the information you need should be on that page. I hope to update a pricing list of what I used. You don't necessarily have to use it. If you Google that and that at GitHub, you should be able to get there. And then all these videos are on my playlist. And there are quite a few of them. So at the end, there are some advanced ones. WebSockets are really quite fancy. This is using the Raspberry Pi instead of the Photon. It has some ability to do camera, higher processing stuff than the Photon. But it does not have analog read, which the Photon is excellent with. So it's a bit of a balancing act there. Your Photon is basically a Wi-Fi out-of-the-box Arduino. Arduinos now have some of those, but the Particle IDE is just such a pleasure to work with. Let's get going with the course. Quick run through of some old projects, all made possible using the Particle Photon. One over here is just it's a Wi-Fi cell phone stand. So it's got a couple of directions of freedom. This is a Wi-Fi mousetrap. Over here we have a Wi-Fi, basically an asset tracker, GPS, can figure out acceleration. Needs a cell phone with a hotspot. Probably better to use the Electron, but I work with the Photon. This is a raccoon detector. It's Wi-Fi. It can text a notification when raccoons are near the garbage. An RF reader project. These RF reader tags, when they're brought near here, it sends a text or a notification. So these are like set things you would use every day, kind of thing. This is a sniffer. Basically, whatever that's detecting, it would then send a text notification. This is some kind of cat toy, the lasers moving with the servo. We have the Pixie camera detecting the color of the cat, so know when to start moving that. Here we got Baby Duck. Basically a nice little project where the speaker quacks. There's a little accelerometer in there. User, when the speaker quacks, would have to rock the baby to make it be quiet. A little app goes with it that can activate the quacking at any time, day and night. Text message or notification of some sort when it goes on for too long, or when it the acceleration is too fast, meaning the baby duck was dropped or something. Nice project here, a Wi-Fi car, 3D printed with rubber wheels, a little servo there, controls the front wheel, and hooked up on Wi-Fi. This one used the WebSocket so that you can control it quite quickly. And over here, last assignment a year ago, student made the hand, 4 servos, these two fingers were connected. And then this year, another student made the glove. First, he just hooked the glove up with one photon to the hand, but the second part of the assignment, he used the WebSocket, and so had to use 2 photons, this one sending the information, this one receiving the information over Wi-Fi, and an app to go with it. I'm not showing you how to do these projects. In this video series, I'm showing you how to have the basis so that you could make whatever you want. My students have to come up with 3 projects. Any one of those 3 projects could get them an A in the assignment. And they have to get it working. Basically, sense something from the environment, send it on a Wi-Fi, either IFTTT or whatever, through an app, the WebSocket, and then have it do something. A great example here is the flex strips here. When these fingers are bent, it sends it off to the internet, and then this one receives the message. This one publishes, oh no, it's WebSocket, so it's totally different, and receives the message, and the hands move. Hopefully, after the credits, I'll blast through a couple of quick snippets of their final movies. The hardest part of this course is when things get confusing, when the teacher doesn't know the solution to a problem the kid's having. There are so many other distractions that students have a hard time concentrating on just solving the problem, searching. So let's use the personal cell phone locker. Lock the student's cell phone in it, either that way up or right way up. Lock it to somewhere on the desk, maybe a computer cable, and let's get to some robotics.
Come and get it.
So this is my project. It is a gas sensor. When it detects a high amount of gas, it makes an alarm go off. There you go.
Alright, the Pixie can see my shirt or sweater because it's focused on green right now, and it can move the laser pointer. And the laser pointer's on.
Okay, to the left.
yeah.
Be showing you the baby duck project here. We're gonna turn it on. Just give it a few minutes to warm up.
I think I did this right.
You hear that? Listen to that bad boy. Hear this? Now you gotta nestle it. You gotta give it some love. Give it some love. Shake that little thing. You hear that? And it's off. We're hoping to pass this class.
There's a window to my soul. Come and get it.
A shout out to Seth, who came up with the really awesome, slightly irritating intro. He also was part of, for his GPS accelerometer tracker, this line of code, which basically it goes into the console with this string here and a latitude and longitude. If we look at the console, it says highlight, then right click. You've got to highlight the whole thing there, right click, and it takes you straight to Google Maps. By the way, those coordinates are for particle.
There's a window to my soul. Come and get it.